Okay, here it's Roger again, always in search of the unexplained at Mudfossil University. And in that endeavor, this is a new phenomena that they have started to study called Steve. And it is a blast of particles that are extremely excited and high energy, and it comes and it lasts for a short time, a minute, sometimes an hour or whatever, not very long at all, and it comes and it goes. Now what I'm saying is Earth is nothing more than a big VanDegraph generator, which means it's scrubbing through electric particles that are the light that is coming from every source in the universe. That's the ether that we're scrubbing through. They're negative particles. We are a coded negative mass, and between the two of them, it starts to bundle up on the ionosphere of our atmosphere, which is completely saturated with these particles. And at a certain point, the capacity to hold them no longer exists, and they discharge. And that, I believe, is the discharge. And they would discharge in a VanDegraph generator exactly the same. It stores, and boom, and it blasts this pulse off and drains itself of its charge. I believe that's what's happening. I believe it may be draining itself. I'd like to see what all of the different astronomical calculations are at these times, but I believe it might drain itself to the moon and then from the moon to the sun. And I have seen these drawings and these sculptures in the past from ancient Egypt or somewhere, someone sent to me, that show this is maybe a possibility. So let's see what they have to say about Steve here in this science here. And here goes.
In July 2016, the European Space Agency's Swarm A satellite flew over Steve, revealing that a previously known phenomenon called subauroral ion drift, or SAID, may explain its unusual properties. SAIDs are narrow regions of charged particles moving rapidly to the west, sometimes at speeds exceeding 5 kilometers per second. Researchers believe that Steve is simply an optical manifestation of an SAID, a phenomenon that's been measured before but never seen.
And not understood.
Thanks to satellite data and observations from citizen scientists, researchers now have a better understanding of this atmospheric feature. In a nod to the original informal name, scientists have suggested that it be called a strong thermal emission velocity enhancement, otherwise known as STEVE. The discovery of STEVE helps highlight the importance of citizen science and the many ways in which professional scientists and enthusiastic amateurs work together.
Well, he did. That's what they say, working together, but I haven't seen much of it. Anyway, that's Steve, and I believe this is a discharge from our ionosphere. Too much electricity in the ionosphere, too many electrons, they shoot back. And now here's what shows in the ancient past. All right, these are what I'm calling light bells, because this is what we see in the experiments we did, Rod and I, with the light accelerated. But you can see they show up, and these are carved, these circular patterns and spirals all over the earth, and nobody's ever understood them, but they're everywhere. Now, I believe the sun, the moon, and the earth is down here receiving this light. And as it comes through space, it is still particles in space. They're everywhere, and it's fully understood. These are extremely strong in this region because this is the source in this region. Out in space, they're everywhere, but they're not in this intensity as we get them from our sun. Now, you notice here at this particular line, it goes back to the moon, like a zit, and then a nice even wave comes across to the sun. Why would that happen? If this was the ionosphere where all the electrons started to collect up here, eventually, just like a VanDegraph generator, it would exceed its capacity to hold them, and it would go somewhere. And they're showing, it's looking to me like it's going to the moon and back to the sun. That's what I'm seeing. Could be totally wrong. Then when you get past this ionosphere area, apparently, they start to decay. And I don't think they just started getting really sloppy the way they did things. They were pretty good. So these crazy looking lines here are what we also see in the light experiments, because this is when these actual particles collide into other particles regions, and then they cascade away and do all kinds of crazy things like this. I'm just guessing at that point. This is not something I can stand behind, but what is that about? And what is this about? Roger once again, Mudfossil University. Today going to be talking about a new phenomena that they've noticed that happens occasionally. It's called Steve, like a person's name, Steve. They just threw that in there for sort of a joke, but it is a beam of particles that they see across the sky, and it lasts for a certain duration of time, very short time, hours or minutes or whatever. We'll discuss it, but it is a extremely high energy, intense particle beam. Now, what is that all about? I think I understand it based on some of the ancient things that I have studied. Now, before we get into that, you just have to understand, first of all, electron flood theory. I've done it a number of times, and if you've been with me, you should understand it by now. There's no neutrons. Light is a particle. It is not just a nothing wave. It's a particle. It has mass. There are no neutrons. The electrons flood the core. Instead of where neutrons are, they are electrons. That's what holds the core together, and that's what repels the more incoming electrons. It keeps them in their orbitals. Now, these are the things that I say. There's a particle size that has a weight. There's a spin and a frequency. It can spin both directions. There's a speed of the particle. That is variable. Einstein was wrong. And I show all these things. I'm not guessing at any of this stuff. The density of the media penetrated, that's quite obvious. And I say that entire space is coated and ubiquitously dense with ether, which is the light particles emanated from every luminous source. There's going to be more dense areas and there's going to be lighter areas. And that is going to be something that's come to play in the redshift, and we'll talk about that because, well, we'll talk about it in a minute. So you have the density of what you're penetrating. You have the motion of the media that it's going. Is the media going that way? Is it coming this way? Is it coming at you? Is it going away from you? And then that all adds up to this equation. Energy equals the mass times the spin times the speed of the particle times the density of the media times the motion of the media. All those are factors. Now, what does that all break down to? It breaks down to the fact that if this electron flood theory is true, which it is 100% true, we actually have absolutely no idea whatsoever where anything is in space because we've judged on the facts that light cannot slow down. And I say light is slowing down. Not staying the same speed, it's slowing down. And the reason it's slowing down is because it's coming through dense or light matter. So what does that mean? It means that from over here it might come fast, over here it might come slow. We always thought it came from the same speed everywhere. So now we know nothing about where anything is. We are literally lost in space. Second thing is that protons must have a half a charge because if I'm correct and the cores are flooded, which they are, the proton of a hydrogen atom is half positive and half negative, which it has to be anyway. Otherwise the electron would be sucked into it. But they come up with all these gluons and weak forces and strong forces and love and charm, and I mean it goes on and on because you can't explain something that's just totally 100% wrong, and that's what they've been doing for the last 100 years. So now that you understand everything's wrong in physics, there are no neutrons, the electrons flood the cores, protons are half the size of what they say they are, and that's why you get so many extreme variations in isotopes. And I got all this stuff down, and I can show you the light being accelerated. Light is a particle. It invades other particles' regions. So let's go on from here. All right, let's just start it off with this. This is what light is. That is the particle. This is the wave. Looked at it from the side, it's a wave. Looked at it from where it's coming at you, it's a particle. It's a right-hand spin spinning towards you. And if you looked at it from the side, it's a wave. That is a high frequency wave. This is like the red shifted wave, red wave, and then it goes deeper and deeper green and so forth until it gets into the blue high frequency region, which is high spin, high impact, high angular momentum. Now, this is what I allege. Electron flood theory. There is no neutrons. Get them right out of your head. They never existed. and I will explain why they never existed. They would roll away, first of all, but let's go beyond that. Now, here's the variables in electron flood, because there's a new equation. M is the mass, which is the particle size, and that's how much it weighs. And electrons and nucleons will weigh different weights. There's going to be heavy particles, there's going to be light particles. There's a spin. All charged particles appear to spin. And when they spin, they can spin to the right and to the left. It's been observed, and I can show you. Oh, I have absolute, solid proof, to me, proof. You can look at it and make your own decision. But I have pictures, and I can explain exactly what's going on from experiments. All right, now, c is the speed of the particle, and that is variable. That is not consistent whatsoever. Now, dm is the density of the medium, and I can prove the speed is the part of the particle is variable, and I can show it accelerated. So I'm not just guessing. Now, dm is the density of the media penetrated, which is the ether in space and in the atmosphere that surrounds us. And I can show that and demonstrate how that concusses and glows and demonstrates and manifests itself in the air right around you. And it is in the atmosphere of the space between the sun and the earth, because it emanates from the sun, it has to get to the earth, and it is a particle spinning through the vacuum of space, not interacting. That's why it's dark. So it's dark energy and dark matter in space. Now, we've got the density of what is penetrating. Out in space, it just spins through very little. There's very little to impact with. When it gets into the density where molecules congregate and turn into mass and turn into Earth, well, you're a whole different situation. It's being pulled extremely strong into the Earth. Earth is an extremely positive source. Now, mm is the motion of the media penetrated in space. So if it's moving away from you and you're impacting it, you're going to have less of an impact. If it's moving towards you and you're impacting, you're going to have more of an impact. All those are factors, and it comes out to energy equals the mass of the particle. And there's nothing that has no mass that is anything. If there's no mass, there's nothing. So forget those things that are nothing. Whatever the mass is of the particle times the spin frequency, how much it's spinning, how fast, times the speed of that particular particle, times the density of the medium it's impacting in, times the motion, which direction that medium is going in relation to the impacting particle. So this destroys, first of all, Einstein, obviously. Secondly, because everything's based on Einstein, it destroys Hubble. And Hubble says that everything's going away and redshifting. No, it's not redshifting because it's going away. It's redshifting because it's slowing down. And now we get into the stickiness of the slowing down. Things don't slow down at the same rate. How was it? What medium is it penetrating through? What was the initial pull to it when it left? So we literally now, if this electron flood theory is true, which it is true, you can trust me, it is true. If you look at the details, you will find it is true. There are no neutrons. The cores of all the nucleuses are flooded with electrons attached to those protons so solidly that they form a dense core which still wants to attract more electrons. However, they collect in orbitals because they can no longer penetrate up close and attach to those positives. They have already absorbed enough. They have been flooded with electrons. So, if what I'm saying is true, and light slows down because it is moving through media that is slowing it down, it's pulling on it, it's attracting it, it's making those Fraunhofer lines move into the red direction, which we call the red shift. All right, so normally we would see oxygen look like this. Well, when it is pulled back, it's going to look like this. And you say, well, that's oxygen because it shows all the characteristics of oxygen, but it's so elongated, it's moving away from us. It's not moving away from us, it's being pulled away from us because of its original attraction from its original emitting source. And as it plows through whatever the density it's plowing through, that will slow it down. So, what we're looking at, we have no idea how far it is away. We've been guessing because we thought they were all moving at the same speed, and they are not. And they will be affected by the density that they move through. Now, let's get a little deeper into this. All right, we're going to get way deep in because it explains every single thing there is. Once you get rid of the neutrons and you decide that light is a particle, which it's seen, and that it can accelerate, which is seen, we're in a whole new ballgame. All right, this is the whole new ballgame right here, and it changes everything, and we have to think completely differently than we're thinking. And it is so obvious when you start to think a little differently. The sun is here, and that we know emits radiation that hits us on the Earth. Absolutely no question. It makes solar cells emit electrons. It heats things up. It lights our Earth and it lights our skies. It makes plants grow. It is particles cascading from the sun out through space, which has nothing for it to interact with until it hits the density of Earth or maybe the space station or whatever it hits out here. It makes them glow because it smashes into them. These are particles. Now, the sun emits those in every different direction. And so does every other luminescent body. So these are things that are coming, these little red arrows are coming from every other direction. So some of them go this way, some of them go that way, this way, this way, that way, this way, that way. And they're coming, they flood the universe. That is the ether of the universe. That is the same thing that our sun does in our region. And they continue on. If they miss us, they just keep going, just like all the other things. The stars we see at night are light that is doing the same thing our sun is doing. So, what can we look at when we think about it this way? The sun itself is an electron source. Everything there is coated with electrons. Everything that we have is coated with electrons. Every atom is surrounded by a coating of electrons. All atoms make molecules, they make matter, they make mass. The mass itself is surrounded, painted by negative particles. So what does that mean? That means as the sun and our solar system is torn through the arm of the galaxy, this negative ball interacts with the negativeness that surrounds it, which is floating in space from all of these light emitting sources, and therefore it creates the same effect that a motor creates as it spins. All right? Electrons pushing into other electrons create an opposition. They create heat, they create force, they create opposition. That's what's happening here. The sun becomes a magnetic ball against magnetic field. So what does that produce? That produces heat. And it's obvious and it is seen. The surface of the sun is 6,000 degrees Fahrenheit. The outer corona of the sun is millions of degrees Fahrenheit, and then you get into the coldness of space, which is nothing until these particles hit it. So if you're shielded from these particles, you freeze to death. If the particles hit you, you burn to death. There is no middle ground. Now, why would this be so hot and this be so less of a temperature? This is scrubbing, ripped through virtual sand of space, of the particles in space that are the electrons. There's some heavier particles. They call them alpha and beta and gamma and all the way down the line, but they were all particles. And some of them are big. The alpha particles are parts of the nucleuses, which have positive and negatives. They're like little bar magnets floating around. And the other ones are just the negative electrons, basically, that are achieved escape velocity and come to us, and those electrons smash into the solar panels and so forth and make electrons here move. So there's no big mystery here. Now, Einstein had it wrong when he said they were photons. They had no mass. They obviously have mass. and they are particles, and I will show you their particles in our light experience. And let's do that now, and then we'll come back to this so that it'll make solid sense to you. All right, so let's look at the experiments we did. Rodney Warren and I did these several years ago, and the detail is hard to dismiss. Okay, I have many videos on this, about this, and this is the light from a pulsed red laser. All these little glowing little dots are the free-floating electrons in the air that is ether. Ether is free electrons. They float from particle to particle. They're extra electrons. They are in the air. They collect on you. They are the static. They discharge from you into ground, which is a positive, enormous positive attractive source. There's a million zillion electrons in there, absolutely, but its overriding attraction is positive. It wants negatives, and you can know that for a fact because you put electricity next to the ground and it goes right into the ground. You get static built up on you, which is these particles, and they want to be attracted to you more than they want to be attracted to the particles in the air. They will collect on you, and then they will want to go to ground if they can get to ground. You will go next to ground, and zip, they go to ground. So these are the particles, these are the ether. These are the particles that also come to us from space, from luminous sources like the sun. Now, so that is just light coming through the air, and that's all it would do. Rodney did these shots, and this is the concussion wave of the red electron beam coming out of the laser light. And I'm calling them electrons. You call it whatever you want. They're light particles. I'm going to call them electrons. Now, here's what happens when that same beam approaches this venturi, which is two round drums, pins sticking down. It smashes into this, and if a venturi forces acceleration, same as a nozzle in a hose, same as the old carbureted cars, it's not some mystery thing. And light is nothing more than a whole batch of particles together in a flow, and they are the same as water, virtually identical. Now, this wave is obviously elongating because it's accelerating. That is the particle beam right there. It is extremely obvious, and the particles are extremely obvious, those little white dots and those little white concussion particles. Now, what is down here? These are the little tiny concussed particles that are the ether that I talked about before. They float freely in the air. When they are smashed into by magnetic waves, which is other particles trying to invade their regions, they glow. These glow. They're trying to get away from me. Get away, get away, get away, get away. They're boom, 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 boom. They're pushing each other around. They glow. That is the nature. I cannot explain that interaction, but they're luminous corpuscles. That's what was said in antiquities. They were right. Ether exists ubiquitously in the universe. They were right. That is the ether. That is the ether. Light is ether in fast motion. Ether comes in slow motion and it comes in fast motion. This is accelerated light. And what happens once it accelerates? It creates this interference pattern, which they've always said was because a wave comes and it pushes it this way and they push and they overlap and so forth. It has nothing to do with that. These are all negative particles. They do not want to be next to each other. They glow and they fight and they push. When they come out of here, they get away from me, and they all say that to each other. It sets up a big band in the middle, and then that sets up the stripes on both sides. Another stripe pushed away, and then they push from both sides. Another stripe push from both sides. That is why you get the interference patterns. I'm sorry, I missed it. The camera wasn't focused in on the interference patterns. Here they are here. And as they exit from the acceleration, they are so forced into each other's regions because each little particle owns a vast region around it that once somebody pushes against it, they glow. Then they push back. Then they become excited. Then they get white. And they get whiter and whiter and whiter until they have achieved maximum whiteness, which is plasma. That's plasma, and it comes out of here. It says, get away from me. Everybody's negative. We don't want to be near each other. They all go their own separate ways as fast as they can, and most of them come straight through the middle in a big blobby line, and then they set up lines coming away from them as negative to negative, negative to negative, negative to negative, and they stripe out in these interference patterns. It's the nature of light. And then this is what happens as it comes towards us from the accelerator. We get these field effects because the particles are so highly accelerated, they set up these huge magnetic fields surrounding the tiny little charged particle carrier, which is called a boson. These are called Higgs fields. And that is from a highly accelerated charged particle carrier coming from Cherenkov white radiation, smashing into a different media, creating a field effect cascade of these polarized fields. And that one right there is spinning backwards, I believe. That's why I say that's one of the parts in the calculation is a reverse spin. There's no magnetic field surrounding like there is the rest. It's highly excited in a central core. It's instead of spinning to the right, it's spinning to the left, and it's capturing its field into itself. It's a very strange phenomenon. It's the same thing that Venus is doing. Now I'll throw a little frosting on the cake. That white particle is that one there. And it is spinning backwards, apparently crashed into one of the standard electrons, which is a light particle. This is light. That's a light particle. That's a light particle. Inside this polarized field is a light particle. That particle, which is the reverse spinning, has captured its own field and held it into itself somehow. I cannot explain it. And it crashed into this field, and it seems to have come and started to create its own field similar to this field, and this is I don't know, that's what it's spit out of there. So light itself obviously has many different characteristics. It can be this, it can be this, because that came from the same source. I don't care what you say, that came from that red light, red laser. There's no can't be any argument of that. They all came through there. They all came out like this except that one. I mean, I'm sure there's other ones like that. This is the only one I really saw that was like that, and the only one I paid attention to. But that's what happened. So what do we have? We have something that's opposite, I think, this, which might be antimatter. I don't know if it's it or not. I'm just looking at it. It's got a reverse magnetic field. It came from the same particle source. I say it's the same particle, only it has a reverse magnetic field. So I don't know what that means really, but I believe that's what they say for antimatter. Now, this gave off, I don't know what that is, but it's certainly not, I don't know, maybe it'll grow to be like this. I have no idea. I don't know. These are the things I'm seeing, and somebody needs to investigate this. I mean, if you had enough people looking at this, it would be something. Rodney and I did this for years, or at least over a year, I'm sure it was, and a ton of work. And Rodney did all of this with the pictures, absolutely fabulous. So, what you have just seen should give you some idea that what we've been told about light and so forth just isn't right. It obviously was accelerated. There's obviously those particles were there. And now we're seeing phenomena that nobody could have predicted. So it needs a little more look. All right, this is where a blue laser is spinning, and you can see that's the particle strobing, and you're seeing it spin to the right, which means it will drift to the left. You can see that it's expanded here and compacted up here. This is as it exits the accelerator in its extreme excited form, and then it slows down and compresses, and then those polarized fields appear. Now, let's look at this. All right, that is the accelerator where they come out all blurry and chaos, and then you say they still get a little white, and then they start to slow down in color, and they appear two waves, it appears, of that particular structure. Now, anytime you see black and white, you know that there's power and no power, energy, no energy, and you can see these spikes sticking up. Now, I have an idea what it might be, and it's a little tricky, but it's capacitive and inductive reactance, which means it can fill up one in the capacity, and as it does, it gets choked into the neck of a torus, which creates inductance, which creates a big, huge field, which opposes the flow, which forces it back up to 10 times the power that it comes in. It pushes it back into a capacitive area, which absorbs it into a big ball, but at the same time creates this inductance because it cannot flow through this little tube. It creates a flip-flop event. That's the only thing I can think of, because I can see there's two different energies here. There's a positive and a negative energy. I don't care how you look at it, that's what it is. There is no other way to take that. So, and it happens in red, and it happens in green, and I'm sure it happens in blue. But, well, here, I'll show you the green. Now, here's the deal. Here's the difference. Red is a longer frequency, so it crashes much earlier into the medium of the unexcited Venturi, because through the Venturi neck, you are just flying. They're accelerated. Now, we're hitting non-accelerated, boom. And at that point, it does this, whatever that is. And the green takes longer, but it does the same thing. All right, you remember the red one had a real blurry, well, it was on the other side, but it was a real blurry coming out of the accelerator. Now, this is much further before it crashes in and starts to settle down back into its regular, original, just floating little disks, waves, actually, particles. Now, this is what I believe we have, is an electron neutrino, which is a high-speed electron which has energy, and it crashes into a different media, which causes electron showers. And that's what we saw in our experiments. And that's Cherenkov radiation. It creates electron showers and these cones. And that's what we detected. And just so you understand, that's exactly what CERN is looking for, is these polarized fields after collisions. Now, they're using high energy particles, the heavy particles, and we're using electrons. It's not totally different. It's totally the same, but it's just on a less heavy scale, and we're not colliding them head on, proton to proton. We're accelerating them back into a media. So it's a little different, but we're getting a similar effect is what they're looking for. And the fusion that we could get from the plasma that we created coming out of that Venturi could create fusion. I don't see why it couldn't. It's plasma. That's what they're looking for, is plasma. We're using electrons and coming out of there, so we're getting those fields, and that wouldn't create fusion. But if you had sent in what they're using here, the protons, the heavy particles, and you sent them in the heavy hydrogens, and then they would turn into plasma through that device. This is just a passive device. There's no extra input whatsoever. Absolutely simplest device in the world. And coming out of there, I would think that you could get plasma. If the plasma comes out the way they want it to, all they're asking for is plasma, and then they can create fusion. That's what I was told. And I'm creating plasma. And I don't see why let's look at it again. All right, let's just say this whole thing was in a vacuum. Everything that I'm going to show right now, is going to be from within a vacuum. There's a proton source that shoots down here, and this is, you see the little beam, those would be protons instead of electrons. But they would be accelerated, and they would go flying down here. Protons have a positive charge. They are just the opposite of electrons, but they have a charge. And I have seen cosmic radiation, which they say is a positively charged nucleus that spins, and I believe I've seen them spin reverse. I can't be sure of that, but I know they were spinning. Let's put it that way. Now, so you have a spinning particle that's coming through here just like our spinning particles, and they are going to crash into that Venturi just like our particles do, and they are going to say, stay away from me, just like our particles do. And when they have to be forced through this Venturi, they will have to become plasma just like our particles do. And what is that going to do? These are heavy nucleuses, and that means that they have extra. They think they have extra neutrons. They don't. They have extra electrons within them. So they will shed those electrons as they come through here, and those electrons will be able to be captured as power. And when they shed those electrons, they will come and combine back together and turn into helium instead of hydrogen. So two heavy hydrogens will turn into one normal helium, and the extra heaviness will be the electrons, because they are electron flooded. They are not neucleuses, I mean neutrons. They say, oh, well, the neutrons turn back into a proton and an electron for some reason. I mean, it's unbelievable. How did a neutron do that? How does a neutron turn back into some positive and negative particle if it's a neutron? There's no neutron, and how does it stick to the nucleus in the first place? Well, there's weak forces, there's gooey this, there's love and charm, and oh man, they just got so many things they can come up with to justify the nonsense. Neutrons are not, there's no neutral anything. Everything is either positive or negative. We saw the particles. The particles you saw, they're positive and negative, and that came from this source of light. Let's look again so you can just be positive. All right, here's a blow-up of it. Here they're coming out, the electrons, or light particles. Call them whatever you want to call them. I'm calling them electrons. But an electron is not just a negative particle. An electron has both a positive and negative. However, it does have a net negative charge. I cannot explain it, but that's what it demonstrates to me. These are all crushed into each other's regions. And they all say, I'm a negative glob here. You're a negative glob. Get away from me. We do not do these things. And when they come out of here, they try to get away as fast as they can. And this is what you end up with, is these particles for two waves come out. Now, if you could look at that and see something different than I'm seeing, I don't know what to say. But when you see a white and a black in this symmetrical pattern, something is going on here. There's energy here, there's no energy here, or magnetism here, no magnetism here, power here, no power here, however you want to say it. But you can actually see half of a spike is dark, half of a spike is white, half of a spike is white, half of a spike is dark. How does this happen? Is that fluctuating as we're looking at it? Why does it display after coming down here for two waves, and then it breaks down? And look at this. This is really interesting. It comes out of here, and you have white on top, black on the bottom, or dark in the middle, and white on the bottom. Then it goes into this. It's like an Oreo cookie upside down here, and then it goes back into the Oreo cookie right side up. You know, after it displays those two waves. Something is going on. It's stepping down. It's like it needs to be investigated. Is the real bottom line here. There's only so much I can do. And Rod did absolutely fabulous work with this Venturi. So somebody else has to step forward, like somebody in a laboratory that has the ability to look at this, because this is not just to prove me, or to prove Rod, or to prove anybody. This is to get, things for reality, to look at things and say, well, let's look at this and see if this is right, if it's wrong. Oh, the guy just had a camera flash. I don't think so. Well, let me put it this way, it's absolutely not. So it demands attention, because otherwise they're just muddling in the dark, hoping for this, hoping for that. There's no neutrons. The speed of light is not constant. Ether exists. Light is a particle. You've got to start from the beginning again.